Dr. Baginski, I think a couple people were struggling to get in the Zoom meeting, so it might be a minute.
Graduation pack came in. Graduation pack came in.
Can you hear me now? Can you hear me now?
Yes.
Yes, sir.
I frankly don't know what's going on. It's got the wrong camera, and I don't know if they did something to this. Let me try this. Hang on. See if it changes. Perfect. Now I've got my overhead. Now let me see what else I can do here. Oh boy.
Your overhead camera. Oh, I was just on the overhead camera.
That's all right. Just hang on for 1 second. Oh, come on. Now which one? This thing is giving me trouble here. I apologize for this. I don't frankly know what's going on. I knew they were having trouble, but
Hey, Professor.
yeah, go
I'm
ahead.
actually a member of Auburn Mail Support, which is also helping on the big Zoom. So if there is anything I may help?
Well, right now, no, but y'all can see the webcam. You can see this document camera, can't you? Class?
Yes.
All right, let me just work from there. Forget about the rest. I don't know if you can anybody see my face anywhere or not?
No.
No.
Good. I don't know what's going on. Anyway, we'll just use this. And you can all see this, right?
Yes, sir.
All right. So does anybody have questions about what was previously assigned, the homework at all? I wanted to cover that first before I get going with the lecture. And I apologize for this. I know they're having problems, and frankly, I just started it like I did last time, and everything seemed to have a problem. So does anybody have homework questions at all? I assigned some homework problems.
Yes, I have a question. Like, I keep on getting the right results, but I think I have a problem with the units. Like, can we do 2.12?
2 point what?
12.
212, okay, hang on. Yeah, we sure can. So 212, let me redraw this, okay? And guys, tell me if you can see this. If you can't, please let me know. I'm going to try to blow this up so I can see it better. And come on. This is not what I bargained for. That's all right. We'll do it 212 as long as you can see it. It has a 12-volt source. All right, 212 has got a 12-volt source here. And then it has a 2K resistance coming down. That's K is 1,000, so that's 2,000 ohms. I hope everybody knows that. And then a 4K resistance. And this is a very straightforward problem. And they want the output voltage here, plus the minus V out. Can you all see this, class? And let me just see if I can get a look at you, because I don't know what's going on here.
It's very blurry for me.
The yellow pad's blurry.
Yeah, everything is pretty blurry, and I'm having a lot of trouble making out your writing your diagram on it.
Oh God, hang on. I'm trying to figure out. Give me 1 second on this. I never had this problem before. All right, hold on. I'm going to try sharing the screen. I don't know how it's going to go. And you should be seeing, I hope, like a mail up on the, just a large screen with a mail. Do you see that, Klaus?
Yep.
All right, now what I'm going to do is try this camera tool and see if I can get it working. Hang on. All right. This is taking way too much time. All right, now, can you all see it now? Class?
Yes.
Yes.
All right.
Yes.
I apologize. Frankly, I don't know what went on. All right, for this problem right here, this is the one you were talking about, right? And that low resistance on 212 is 4K, right? Class?
Yes.
I mean, I want to make sure you all hear that. I mean, you all see this. So this is 12 volts. Now, this voltage, V out, we can calculate several ways. If you just use the rule I said for voltage division, it takes the source voltage, which is 12, then it multiplies it by the value of the resistance you want the voltage across, which is 4,000 or 4K, and it divides it by the sum of 4K plus 2K or 6K. Can everybody hear me and see that, class?
Yes.
Yes.
Y'all good with that? Now, I, for some reason, can't see you, and I don't know why, but I'll just go with it. Now, if you look at this, the K's cancel, that's 1,000. That becomes 2, that's 3, right? So it's really 2 times 12 would be 24 divided by 3 would be 8 volts. you all see this, class? Now, somebody asked a question about units. Whoever asked that, you'll notice this 12 has the unit of volts. These have the unit of ohms, so the ohms cancel, and the output is in volts. Did that answer your question, miss?
Yes, it does. Thank you.
All right, now I want to mention one other thing about this. If everybody's watching me, I just wanted to make sure everybody sees this. If I asked for the current, somebody else, not you, miss, here, what would the current be? I. People? Anybody? Say again?
Voltage divided by resistance,
What's the total resistance? You're right.
6 kilo ohms.
Right, so it would be 12 literally divided by 6,000 ohms. Do you all see that, class?
Yes.
Can you all see that? Boy, I'm sorry, I can't even see your thumbs up or anything. Maybe there's something I can do. I don't know.
I had a question.
Go ahead.
So in the book, it looks like at the power source, like the minus is actually on top and the plus is on the bottom.
I'm sorry. I got it backwards. Sorry. Let me go ahead and correct that. I just wrote it this way. You're absolutely right. In the book, he had this. He had minus on top, plus on the bottom. You all see that, class?
Yes.
I'm sorry, you're going to have to speak. I have no visual on you guys. All right, well, if that's minus, then this voltage is literally a minus 12. Now, I'm going to spend more time with the polarity because what you end up doing is saying that I'm going to have to go through this a little more carefully in a bit. But you all see how current will flow out of the positive. It'll be flowing this way. Do you all see this, class, counterclockwise?
Yes.
Can you all see that, everyone?
Yes.
So if it flows from the plus to the minus, that means the actual voltage will be developed plus to minus here and plus to minus here. Now, here is a great opportunity for me to explain to you polarity in a much better way because I didn't realize there was a negative sign there. I didn't see it in the book, but this current is actually flowing the opposite way that I showed you. I showed you the current flowing this way. The current flowing that way would be minus 12 over 6,000. Or it would literally be 2 times 10 to the minus third amps with a minus sign. Does everybody see that, class? If this is a minus to plus, then if I want the current in this direction, it would be minus 12 divided by 6K, or minus 2 times 10 to the minus third, and that's really minus 2 milliamps. Do you all see this, class?
Yes.
I'm going to try to get a picture because this is starting to really irritate me that I can't see anybody. But maybe I'm just going to be stuck with that for this lecture. All right, that's all right. But you're going to have to speak up because that's the only way I'm getting feedback on this one. All right, if that's minus 2 milliamps, what it really means is this. Positive current is flowing this way. If I put this as plus here and then define the current this way, I hope you can see it. This way, that would be a plus 2 milliamps. It's flowing out of the positive back to the negative. Now, having said this is a perfect segue into what I really wanted to get at. Is everybody okay with what I just said?
I have a quick question.
Yeah.
Due to the fact that it's like flowing from the negative to the positive, does that change the
Actually, the current is flowing from the positive to the negative. Actually, the current always flows from the plus to a negative with one source. That's positive current. However, if I ask for the current, and you could say in the wrong direction, that it would be negative. Now, let me explain something. Remember how I said how current is like water flowing in a pipe?
Yes, sir.
Y'all with me? Now, follow me on this. This is important. It wasn't how I planned to do it, but it'll work. Well, if you have a pipe, and I say there's 30 gallons per second flowing this way. I'm just saying gallons per second, okay? That is the exact same thing as saying minus 30 gallons per second is flowing that way. Do you all follow me?
Yes.
Everybody follow me on that? Polarity gives an indication of direction. Positive that way is the same as negative that way with the same magnitude. Do you all see?
Yes.
Yes.
All right, now, when we talk about real current flow, and please pay attention to this, I'm just going to use a standard battery. If I have plus to minus V, and I have a simple resistance R here, and now I want you to pay attention to this. I'm going to cover two things. First, I know if I go by the standard convention, positive current leaves the positive terminal and enters the negative terminal if I have a single source. I know the current here, I, would be equal to V over R. Do you all see that?
Yes.
Boy, this is irritating as heck. I got no indication of what you guys are looking like or anything, but that's just tough. I'll deal with it. Now, if that's the actual value of the current, I want you to listen. This is very important. This is plus to minus voltage. You notice this is plus to minus the same voltage V there because these wires have absolutely no bearing on the voltage change. There is zero resistance. Does everybody see what I'm talking about?
Yes.
All right, now listen carefully what I'm about to say. The book does not quite get into the details. Well, I apologize. I'm not sure about this book, Gross and Roppel's book, but I want to be absolutely clear about this. Now, the way we define power, and write this right under there. When we define power, the units are watts. But this is how we define power, and then I'm going to tell you what is absorption of an element and what is actually a source of power. When we have anything, doesn't matter what it is, if I'm just going to put a block here, in his book he does this, I'm going to call it A. Doesn't matter what it is. If I say the current is equal to I, and it's into the terminal that is positive. So always when we're talking about power, we define a plus and minus sense to the voltage across the element. This is positive, this is minus, all right? Now, if this voltage is V, y'all see what I'm doing? Positive current is entering the positive terminal. Y'all follow me on this, everyone? I want you to make sure you see this.
Yes.
And I'll go through all the permutations that can foul you up. The actual power is considered V times I. In this case, if that's positive current, and that's positive voltage, this would be a positive value. All right, it would be quantity VI, and the unit would be watts. It would have a positive sense to it. And if it has a positive sense, this is absorption.
Could you slide the paper up a little bit, please?
Yes, thank you. So if it's positive current entering the positive terminal of the voltage difference across a element of any type, then this quantity V times I is positive, and it is absorption. That's a lousy spelling or writing, but it means it's absorbed. Y'all follow me? Now I've got to get another piece of paper, so just bear with me, and I'm going to go through some examples to really try to show you what I mean by this. I want to be absolutely clear about this. So when we have a standard source, a battery, and y'all are familiar with what a battery looks like. I'm just going to say this.
Up a little bit.
Actually, that's my just. Yeah, it's all right. Doesn't matter. I got you. Yeah, yell at me whenever this is not on the screen. It'll should be self-focused in a second. Come on. Irritating little thing, isn't it? There we go. All right, I'm going to go ahead and put a real value here. So I'm going to put 10 volts, all right? Then I'm going to put a resistance. I'm going to actually make this a little more complicated. I'm going to put a resistance of 5 ohms here. Some of you will be bored to tears with this one, but it's necessary. I'm going to put 5 ohms here. Y'all with me? Now, I'm going to go through a few things about power. First, what is the current flowing here from the positive to the negative terminal? This current, anyone?
1 amp.
Yeah, it's 10 volts. These are 5 and 5 in series would be 10 ohms. Do you agree, class?
Yes.
All right, so it's 10 over 10, and that would be amps, so it's 1 ampere of current. You all agree? Now, follow me on this. Current is leaving this terminal, right? It's leaving the positive terminal, right? Follow me?
Yes.
1 amp's leaving. It's like what? minus 1 amp going into it. You all follow me? I want you to say
1 amp.
minus 1 amp going into it, right? If 1 amp is actually flowing in this direction, if I go in the opposite direction, it'd be like a minus 1 amp, right?
Yes.
Can you all, everybody say? Now that means the power associated with that would be equal to, well, the current entering the positive terminal is minus 1, so it'd be minus 1 times
Everything's eventually
10,
the same.
10 volts, all right, 1 amp times 10, or it's equal to minus
I think
10 watts. Do you all see that, class?
Yes, sir.
And if you see that, that is a source. Whenever, S-U-R-C, whenever you have a negative sense to the actual power, if you take the current entering the positive terminal on the source and multiply it by the voltage on the positive terminal to the negative,
Positive.
and it's negative, that is a source. Y'all with me,
Yes.
guys? All right.
Yes.
Now we're going to keep going on this, and you're going to see something. That's minus 10. Well, how much power is being delivered to this? Now, you can get it a couple different ways. If I want the power in that 5 ohm, I said that was equal to either V times I. Do you all agree with that, class? Positive voltage, current going to the positive terminal. Or it was equal to I squared R, right? How many remember was I squared R watts? Class?
Yes.
And you get this by just saying V is equal to I times R, times I is just I squared times R, right?
Yeah.
People? Here's one other thing. Resistors only absorb power. They can never supply power. That's sort of self-intuitive, but they can only absorb power. A resistor could be something that's modeling a light bulb, a heating element, something like that. Well, if you have that, I is 1, R is 5, so there's really what? There's 5 watts being absorbed by that resistance. Do you all agree?
Yes.
There should be a way for me to at least see your hands on this somewhere. I don't know how I'm going to see them, but. All right, I guess.
There's
Forget
like a yes at the participants.
What's that?
There's a like raise hand yes no button at the participants.
Yeah, I know, but I don't see that. The problem is my screen overrides that. That's the problem I'm having. And but let me just go with the flow on this one. So that's back. Hold on. All right, now you should see this. No matter what I do, I can't see you right now. That's anyway, that's going to be 5 watts. Can you all see my little cursor on here? This thing, this cursor, class?
Yes, but very laggy.
That's all right. If that's 5 watts here, how much is here? Anybody?
5 watts.
5 watts. Now, what do you notice about this? If you sum all the powers in a circuit, you get 0. Do you all see that? If you have a closed circuit, if you sum all the powers associated with all the elements, you'll always get 0 watts. The same power that's delivered is the amount of power absorbed. Are we clear on that, everyone? And God, I wish I could see it, but I'm sorry I can't. If somebody can see chat, just tell me if there's a question or somebody doesn't see this, and I apologize for this whole mess. We good with that, class?
Yeah.
Okay. Now, that's important because power is something we'll be dealing with, and for the mechanical engineers and aerospace engineers, and probably industrial to some extent, you're going to be using the concept of power for a lot of things, especially power conversion. I want to mention one thing. I don't know how many people have been keeping up with what's going on with drone delivery systems. Many of the drone, they're going to be wide scale. They're going to be all over the world. That's for the mail and other packages, as well as actually probably emergency medical stuff. Anyway, A lot of these things use electrical to mechanical systems. They have electrical power to a propeller that will be a mechanical device, things of that nature. And power conversion and understanding the concept of power becomes very critical. So I'll leave it with that. All right, that is 212, and I'm sorry this is taking so darn long. Did you have another question about the homework? I usually take at least 2, and I'm so sorry it's taking so long. Anybody?
I have a question about the very last one. I think it was 2.18 with voltage division, or maybe it was 2.17.
Take a look now and tell me which one it is. We'll do one of the two.
It was 2.17.
All right, I'm gonna, if you take a look at the homework, 2.17, here, I'm gonna redraw it. It shows you 36 volt source. I hope I got the polarity right. Oh, no, I don't. Oh, God. The polarity is this, plus to minus 36 volts. And then they have 4K ohms, and then they have 8K ohms. Whoever asked this, do you agree that that's what's shown?
Yes.
And they asked for this voltage, right? Plus to minus, right?
Mm-hmm.
All right, now again, you'll notice the problem is the polarity. Here, they have polarity not with positive on top, but negative, right?
Yes.
It means this, current is actually, positive current will flow this way. Now I want you to follow me on this. And I'm going to make another statement in a second that gives you more clarity on how to determine polarity. I'm sorry about this thing coming out of focus too. There we go. All right. First, you all agree this current going in the counterclockwise direction, I, would be the voltage, which is 36, right? It's 36 volts divided by 12K. Do you agree with that?
Yes.
And that would be what? 3 milliamps, right?
Yes.
Now I'm going to show you this 2 ways. This is the first way. Now if current's flowing in that direction, current enters the positive terminal of the resistance, leaves the negative, enters the positive, leaves the negative. Do you see that?
Yeah.
That means this voltage right here, now you'll notice the way I've drawn it, positive to negative, this voltage right here would be equal to 3 milliamps times 4K, or this voltage right there would be 12 volts. Polarity plus to minus. Do you see that?
Yes.
I'm doing it this way for a reason. Now, if you see that, now here's what I'm going to say to you. Think about a car battery. Car battery is 12 volts, right? I'm going to draw a car battery, and I hope you can see it. I'm going to put a terminal here and a terminal here. I'm going to call that plus, that minus. This is 12 volt car battery, right? Y'all see? Can you all see this?
Yes.
Yeah.
Yeah.
All right, now take a voltmeter. You know what a volt-ohm meter is, right?
Yes.
All right, take that. It'll have a positive lead and it'll have a negative lead. Take the positive lead and put it at the negative point here. Take the negative point and put it at the positive lead there. What does your meter read?
Can you push the paper?
Page down a little.
Yes, yes, thank you. If you have a positive here, minus 12, right? Because what you've done is imply the positive polarity is from here to, and the negative is here, what's called the ground that I'll get to in a bit. What you're actually measuring is the magnitude is correct, but the sign is wrong. Correct, class?
Yes.
All right, now look here, same deal. Think of this as a meter, a voltage meter. I hope this helps. Put the positive polarity right here. You see it's got a negative right there? And the negative polarity right here. You see it's got a positive sense to it? So the voltage you're reading would be equal to minus 12 volts. Are you with me on that? Can you all hear? Can you hear me, Miss? I'm really trying my best to make it as simple as possible. Now there's another way to do that, and I'm about to introduce it to you. Are you ready? Okay, I hope you are. Are you guys, y'all, any other questions about this before I show you something? Okay, hearing
Yeah,
now.
I have a quick question real quick.
Go ahead.
What would be the voltage if you were to measure it at V naught there? You know, you have a positive current going into the negative terminal.
Wait. When you say V naught here,
Yes. So if it's flowing down,
that would be minus
the resistor.
minus 12 volts, right? Because there's 12 volts dropped across this resistor, but the plus side is this way and the negative side is that way, right?
Right.
So you would be measuring minus 12 volts. Just like if you were measuring a battery backwards, think of it that way.
So after you've crossed the 4 ohm resistor, you have 0 volt?
No, that's 12 volts here. But this is what I was going to get at today is Kirchhoff's voltage law. The sum of the voltages around any closed loop will be 0, and I have to get to that in a second. Remember, we have current flowing in this circuit, right?
Yeah.
That means there is a voltage here, and the voltage would be that current, which is 3 milliamps times 8 kiloohms, right? Voltage is like potential. It's like pressure. So 3 times 8 would be 24 volts. If I was to actually do this in color, this would have a voltage of plus to minus 24 volts, and this would have a voltage of plus to minus 12 volts. I'm going to make a point. Does everybody see the way I had the polarity and magnitude of the voltage here? Guys?
Yes.
Yeah.
Now, here's the thing. This is called Kirchhoff's voltage law, and I'll spend more time on it in a second. If you take any point in a circuit where there's a closed loop, in other words, if you start here and you sum the voltages, you come back to this point, the sum of the voltages will be 0. And I'm going to show you how to actually find out about the sums. But I want to do this on the next page, if you don't mind. I'm just going to show you this. And I'll take that example. We had 36 volts here. Excuse me. We had minus the positive 36 volts here. Then we had 4 ohms here, right? Or 4 k ohms, whatever it was, 4 k ohms here. And that gave us a plus to minus 12 volts. And then we had 8 k ohms here. And that gave us a plus to minus 24 volts, right? Please realize I'm just redrawing what I had. Are you with me, class?
Yes.
Yeah.
Now, when we add voltages, if you start at any point, I'm calling it point A. Kirchhoff's Kirchhoff's voltage law, it's called KVL, says if I start at a point and I sum the voltages around the circuit, a closed loop, I get 0. And here's what it means by that. If I start at this point and I'm summing voltages, now listen, if I hit a plus sign to minus sign, that's going to be a decrease because the voltage on this side is 36 volts greater than the voltage on this side. Does that make sense to everybody?
Can you press the paper down, please?
Oh, yes. If I start here and I'm going around, you see I'm hitting the positive side of the 36 volts. Everybody?
Yes. Yeah.
Now, that means this side is 36 volts greater than this side. So when I go through here, it's a voltage drop. If I look at this, it would be actually minus 36 volts if I'm going around this way. Y'all see that? I was here and I went to here. It's 36 volts drop or minus 36. Y'all see that?
Yes.
Now when I go here, what happens? I went from a negative to a positive, so it would be an increase of 12, right? Class?
Yes. Wait, so at what point are you
Yes.
starting with the negative 36?
I'm starting right here at A, and I'm going this way. I'm going clockwise. You see how I hit a positive sign first?
Yeah.
That means this side is 36 volts greater than this side, right? Whatever this voltage is, this side's 36 volts greater, right?
Yes.
All right, that means I'm decreasing the amount of voltage. This is a drop of minus 36. Now when I come here, I'm going around, I hit a negative sign. You all see that? And when I go from this side to this side, it's an increase of 12, plus 12. Y'all follow me?
Yes, sir.
Then when I go from here to here, it's a negative to positive. Now it's an increase of 24, right?
Yes.
And that equals 0. And that's Kirchhoff's voltage law. The sum of the voltages around any closed loop is 0. It's a very important law. Y'all hear me about that?
Yes. Yeah.
And hang on just for 1 second. I'm going to try one thing here just to try to help my sanity. I don't know if this is going to work, but I'm going to try. Okay. This ain't going to work no matter what I do. All right, let me get back to this. So that's Kirchhoff's voltage law in a nutshell. And I'm going to show you some more about this. I want to just mention that's Kirchhoff's voltage law. I'm going to mention the second law. Please stay with me on this one. And if you don't mind, please just bear with me if I go a minute too over, because this has been a technical problem-filled class. The next is going to be Kirchhoff's current law. It's
Sir?
This is.
Your screen is very fuzzy.
Yeah, appreciate that. This is supposed to be an autofocus camera. There it is. The next is Kirchhoff's, huh?
Can you go down?
Well, I'm writing right here. Okay. Can you see it?
Yes.
Can you? All right. And the next is Kirchhoff's current law, KCL. It's really Kirchhoff current law. And don't worry about the name. It's KCL. And what it says is this: the sum of the currents, the way they usually write this is the summation sign of the currents entering any node is equal to 0. Now, I got to explain what a node is, and I'm so sorry I'm running short on time. If you have something like this, and this should make sense to you, think about current as being water. If I call this I1, you'll notice I1 is flowing into this point where there's more than one way out. Do y'all see this, class? That's all a node is when I talk about a node. And in the book, they'll talk about a node. It's a point where current can go in one way and out more than one. And I'm sorry about this not being sharp. There we go. Y'all follow me, class? Now here, if I call that I2 here and then I3, what Kirchhoff's current law says in a nutshell is that whatever goes in comes out of a node. Think of water flowing in pipes. Whatever goes into a junction in a pipe is coming out of the pipe in terms of flow rate. That should make very good sense to everybody who's an engineer. It's intuitive common sense if it's an incompressible fluid. Now, for this one, I1 is going in, and that means I2 plus I3 are coming out. So this would be the equation that dictates that. Does that make sense to everybody?
Yeah.
And I'm sorry I've got to ask you to do that, but it's the only way I can get it, because my screen for some reason is just, it's masking the usual visuals I have, and I'll try to figure this out next time. And it wasn't that way last time, and it wasn't ever that way, so I don't know what happened. Now, if I'm going to give you a concrete example about this, all right? Suppose we have this. Suppose I have a current of 20 amps flowing in, and I say this current here, call this I1, I2 is equal to minus 10 amps, all right? Now remember, I'm showing the direction of I2 is this way. And then I'm saying this one, I3, is equal to 40 amps, all right? And then there's an I4 in this direction. And I want to know what I4 is. Y'all follow me, class? I got I1, I2, this is supposed to be I3, and I don't know what I4 is. Are you with me?
Yes.
Yes, sir.
Now pay attention to this carefully. What goes in? By definition, by the arrow pointing, 20 amps, right?
Yes.
Just 20. Now what comes out? Well, I2 comes out, but its value is minus 10. You all see that, class?
Yes, sir.
That means you're putting minus 10 there. Don't worry about the sign. This one's coming in this direction. It's 40, right? Right?
Yes, sir.
Yes.
And this is unknown, so it's plus I4. So what is I4 going to be? Well, I have 20 on that side, and I have what? I have 30 on this side plus I4. Agree, class?
Yes.
Yes.
And that makes I4 what?
Negative 10.
Negative 10.
Minus 10 amps. Very good. And actually, that means that I4 here, the positive sensed I4 would be going in the opposite direction. Are you with me, class?
Yes, sir.
I'm sorry I have to ask this, but I have to. Hang in there, all right? Now, that's Kirchhoff's current law. You haven't seen it applied to circuits yet. I'm trying to cover some things. The next thing I want to cover is the concept of grounding or a zero potential point, because this will start to really help us with problems. And I don't want to fly through it. I want to make sure it's clear. Now, people have heard the term ground all their life, basically, but they don't know what a ground really means. When you say ground, it means what we're assuming is zero potential, or the voltage at that point is assumed zero to anything else. So if we have a voltage source like this, and I'll put it 12 volts, and then I'll put a resistance here, and make that 6 ohms, and a resistance here of 6 ohms, and I have this circuit. That's a standard circuit. We could calculate the current, we could calculate the voltage, we could calculate all that. But here's what grounding is. We're going to say one thing is going to be the zero potential point. Almost always, if you're given an option, you take the zero potential point as the thing that is going to be actually, it is going to be at the bottom of the circuit where this line comes from the negative terminal. Just put this symbol down. This is called a ground symbol. It's GND is the actual abbreviation. It's ground. It can be this way. Sometimes you'll see it as this. You don't have to worry about the difference between signal grounds and earth grounds and different things like that. Some of you in mechanical engineering will get into this more. You don't worry about this. This is called zero potential. It means the voltage here is assumed 0 volts right there at this point. Y'all follow me? Class?
Yes.
Yeah.
Now, the reason I say this is it means this right here with respect to 0 volts, this point right here is going to be 12 volts with respect to ground. Y'all follow me?
Yeah.
Now, there's an unknown voltage here. It's not unknown, but there's some unknown voltage here. You got me on that? We don't know what that is with respect to ground yet. We kind of do, but just go with me on this one. All right? Class?
Yeah.
Here's how we figure it out. Now, I want you to follow me on this. I'm just about out of time, but bear with me. First, I'm going to go back and revisit the actual concept of a simple resistor and current. When I had a resistor before, R, I said the current through this, I, was equal to the voltage difference plus to minus divided by the resistance. I said that I was equal to V as measured this way divided by R. Correct, class?
Yeah.
Now, this is a voltage measurement across the resistor. It's between one side and the other. However, if the voltages are measured with respect to ground, and we have this, we have R, but now we have some V2 on this side, call it V2, and we have V1 on this side, and I want the current going from V2 to V1. I want you to notice the direction of the current becomes critical. Do you all see this?
Yeah.
Now here's what happens. You put the direction of current dictates the side you consider positive. And this side would be considered negative. Do you follow me? Now, you say the voltage across here, which would be V2 minus V1, you take the voltage on the positive side and subtract it from the voltage on the negative side, doesn't matter what the sign is or the magnitude. Whatever that value is with respect to ground, you take it, put it there. Whatever this value is, you take it and put it there. And divide by R, that's equal to the current I. Do you all see that? How many see that? And I can't see your hands, so just say something. I'll figure this out next time, and I apologize. Y'all see it?
Yeah.
You guys? All right. That's it. Now, let me give you let's go back to this and revisit this. Here, we don't know what this voltage is for now. Just assume we don't. You with me on this, class?
Yeah.
Yes.
We know this current right here, as I'm drawing it, that current I would be equal to voltage on this side minus the voltage on this side divided by 6. I'll call it I1 right there. Do you agree with me? It would be 12 minus V, right, divided by 6. That would be the current. Do you agree with that, class?
Sure.
And the current here, I'm just doing this for the sake of making it obvious, I2, the current here would be the voltage on this side, which is V, unknown, minus the voltage on this side. What's the voltage on this side?
0.
It's 0 volts because I put a ground in, right? Y'all see that, class? So it's minus 0 divided by 6, right? And you'll notice what flows in flows out of this node. Isn't that true, class?
Yes.
What flows in flows out, or I can say I1 is equal to I2. What do you see? Well, I1 is 12 minus V over 6 is equal to I2. It's V over 6, right? Can you all see that?
Yes. Yes, sir.
I'm just saying I1 is I2. Do you all agree with that? That's whatever comes in comes out of a node. In this case, we only have one thing going in, one thing going out. Now, what do you see? You can get rid of the 6, right? And you take minus V to the other side, you get 2V, or you find V is equal to 6 volts. Don't you, class?
Yes, sir.
Now, that's using, it's a very simplistic way, but it's using the concept of Kirchhoff's current law. Whatever flows in, flows out. And we get this. Now, I know I'm out of time, and there were some problems with my with the stuff here, and I'll figure that out next time and make sure it's not a problem. I've never had this happen this in the summer or in the spring, so I don't know what exactly is going on, but I know we got messages that we're having trouble. And it's probably my fault, not the university's, so I'll figure it out. I'm going to give you some more homework. This is technically an office hour. If you need to leave, go ahead and leave. All right, and I appreciate it. Thank you for tolerating this problem-riddled session. But now, if there are people that have any questions, let me know. Let me just see if I can actually do something here that makes life.
Dr. Baginski?
Yeah.
Do we have a quiz this week, or is that starting next week?
No, we don't have a quiz this week. And don't worry, I'm not going to criticize you if you didn't hear me before. There's no quiz this Friday. It will start next Friday.
Okay, thank you.
Let me do one other thing here. Can you all still see me, class?
We just see the notepad in front of you.
Well,
Just a note.
Space cam now.
Now we can see
Okay.
you.
Now we can see you.
All right, and I could see one other person. I'm trying to get the whole group here, and I'm trying to figure out. Hey, whoever is in charge of technical assistance that was talking, what did you say about what I can do? I see managed participants. I'm down to 34. everybody's jumping ship, and I can't blame them. How do I get to see everybody?
At the top of your screen, do you see a bunch of videos, small little cameras?
Nope. I got nothing.
All right, try pressing participants on toward the bottom of your screen.
Got that? Yeah. What now?
All right. Kind of hard to do this without seeing your screen. Kind of hard to do this without seeing your screen.
Okay. I'll tell you what. Hold on. I've never, ever had this problem. I hope I don't have it again.
If you can do screen share so he can see your screen.
Yeah, I can do that, but I'm gonna have to stop this share. I'm gonna exit that, and then I'm gonna screen share this screen, okay? Are you still there, my technical support fellow? Are you there? Can you see this screen?
Yes.
All right, this is what I'm seeing. Any ideas?
One second.
All right, there's my video. Here's the participants. And I don't have any idea how to get them back.
There is an option called gallery view. I'm not sure if that can help.
Where is it?
I'm seeing, okay.
Is it here? I don't know where it is.
Try moving your.
Say again?
I was going to say, try moving your camera screen over to the left. I think there might be an icon hidden behind it.
Are you still seeing this screen?
Yes.
I can see your desktop now.
Yeah. There's no icon that I can see.
I was saying on your, if you open Zoom back up.
All right. This is Zoom, right? This is what you're talking about, this thing?
Yes.
Or maybe you're talking about something else. Are you talking about this? I can see somebody.
If you go to where it says participants, and then go to the little down arrow that's next to that.
Wait a second. There's no down arrow next to participants.
Okay, so see where it says Zoom group chat or participants, whichever you like. There's like a little down arrow, and you click on that, and it'll say close, and you close it, and then there'll be an option for gallery view.
Wait a second. This part, can you see what I'm seeing? Or not?
Yeah, we can see it.
All right. I see participants. I see no down arrow. What are you seeing a down arrow?
Next to the word participants.
Manage participants? Or here?
Right there. Now go to the left. It's like a little down arrow.
Here, you mean? Right there? Are you seeing what I'm seeing or not,
Yes,
Miss?
that arrow. Where's your?
We can't see your mouse.
Yeah, we can't see your cursor.
Can you see? You can't see this curve? All
There
right,
it
now look. I'm going down. You see this arrow?
Okay, go, Dr. Brzezinski, go up to where it says participants over on the right side.
Manage participants or
No,
right
just the
here?
word participant.
The top
Oh, this is up here. Yeah, this is up here. Okay. Yeah.
That
Go ahead.
drop-down arrow right there to the left of it.
There is no drop down arrow. Oh, this one.
We're looking at it.
It says close or pop out.
Close. Click close.
Okay. Yeah.
Now try closing the chat.
Do the same thing. Do the same thing with that little arrow that's next to Zoom group chat. Click on the little arrow and then click close.
Okay. We got 11 people and I see somebody's picture.
Emma.
I don't, this is just one of them things that happens every once in a while. Things go batty. I honestly think I know what you're talking about, but I tried that all.
See, Dr. Baginski, our gallery view is like under where that green bar is. Like where it says you're sharing the screen, like that's where we have the gallery view option.
Well, I stopped sharing. And is it here?
It's usually up top in the top right-hand corner.
Well, I hate to tell this, but I'm not seeing it.
All right. I'm able to switch between thumbnail video and the gallery view. So,
say that again?
Do you see the little icon that shows just your camera?
Yeah.
All right.
Right here?
Yes. There should be different options. I have grid video, thumbnail video.
I don't. I have this.
I only see your camera right now.
Oh. Well, I have I have three things I can hit. I think there's something messed up, to be honest with you. And I'm going to level with you. I know what you're talking about, gallery view. I was looking for that too. I haven't seen that, and I don't know what, in fact, is going on.
I have one last ditch effort. If you go to the top right of your screen, do you have the full screen option?
Yeah. I mean, I did. Hold on. Let me shut this down. Hold on. Close. Yeah, I've got this full screen, right?
All right. So if you can see the full screen option directly to the left of that, it should say speaker view or gallery view.
There's a full screen. To the right, there's nothing.
To the left of it. All right.
To the left.
Try Alt F2.
Nothing.
All right. It might be different because you're the host then.
I love it with you. This is the first time this has happened, and we were warned they were having a lot of problems with this, and I don't know, maybe something got disabled or something, because I really don't have a clue what's going on. I'm looking.
A smart ass, but like sometimes the sage old wisdom of trying to turn it off and turn it on again just works.
Yeah, if I shut everything down, you're going to get kicked out. Is that what you're talking about?
Yeah.
Yeah, that might work, but is that what we want? I can tell you what. Why don't we do this? I'll work on this with somebody that knows, with a sim or one of these people that's in charge of this, and see if I can straighten it out. Now, I personally apologize to everybody about this, but I'll get some homework up on OneNote, okay? All right, while I'm still here, does anybody have any further questions regarding the technical stuff we covered or anything prior?
I have a question. You went through the homework 2.17, but like I got the same result, but I did it in a different way. So I'm trying to see. So how do I say it? For the VO, how I got to -12 was by multiplying -3 times 4. And
3 milliamps, you mean?
Yes. Mm-hmm.
Times 4. Yeah, that'll do it too, because you calculated the current to be negative. That's right.
Yes. Okay.
Yeah, that's right.
Thank you.
So I'm not quite sure I understand ground.
Say that again, sir?
I'm not sure I understand how ground.
How grounding works? Oh, all right. I'm going to have to try to get a camera up here, so just hang on. It's actually not a hard concept. Are you a mechanical engineer?
Materials.
Materials? Okay. Give me 1 second. I got to turn this on. That's the first time ever I've had this problem, by the way. Never before.
I know, that's so weird, Dr. Baginski. I don't know what's going on.
Well, I've taught in the summer and in the spring, and that's a first. So the only thing I can tell you, I have a feeling there's something going on with the system that I'm not aware of. They've already warned us yesterday and today. Expect difficulties, anticipate problems. But this is a first for me to have any of that. Now we're getting things about class pictures being messed up. And I think he's talking about the visual we're trying to get. I just got a message about that. So maybe what we're having happening is not just to me, it's everywhere.
Dr. Baginski, are we going to go over KVL and KCLs and grounding
Yep.
for class?
We sure are.
Okay.
And if my camera ever comes up, yes, we are.
Okay.
Hang on. God, this is weird. I'll tell you what, this is frustrating for a professor, because what you learn to trust will be there is not there. Now my camera, come on.
Yeah, and Dr. Baginski, I tried making the group me, but someone beat me to it.
That's all right. It's out there, right?
Yeah, it is. We're good.
Now what's going on here? Now my camera's not working. Hold on. Let me stop recording this.